Introduction to Computer Architecture by Clodagh Brennan, Lorcan O'Connor and Emma Fitzpatrick. The Central Processing Unit. The Central Processing Unit is the brain of the computer. Without this, there is no computer. CPUs are so small that sometimes they are referred to as microprocessors. The CPU is composed of control unit, an arithmetic logic unit, registers, a clock, and wires which connect everything together. The arithmetic logic unit performs all the arithmetic operations and logic operations. The arithmetic logic unit has three sections: the registry, the ALU circuitry, and the pathways between. The control unit is the circuitry that controls the flow of information entering and leaving the computer, maintains order throughout the system, and directs the flow of the operations. The clock is a circuit in the processor, which generates a sequence of electronic pulses which synchronize the operations in the processor's components. Registers. Registers are temporary storage units within the CPU. Different registers store different things, and some registers, like storage, interpretation, and execution of instructions, and the intermediate results, are for exclusive use for the CPU. Von Neumann architecture. A von Neumann architecture computer is 5 parts: an arithmetic logic unit, a control unit, a memory, some form of input-output, and a bus. Virtually every electronic computer ever built has ties to this architecture. Northbridge-Southbridge chipset. The function of a chipset is to communicate between the components of a modern computer. Chipsets are made up of a number of integrated circuits designed to perform one or more related functions. Each part of the chipset has its own tasks and specific functions. Northbridge chipset. The Northbridge coordinates high bandwidth pathways. Northbridge determines the amount, type, and CPU speed that can be attached to the motherboard. The Northbridge interacts with the computer, processor, and memory. The Northbridge is the high-speed part of a chipset architecture in a computer. The Northbridge connects the CPU to RAM, AGB bus, PCI Express, and built-in display adapter. Southbridge is a chipset that manages the basic forms of input-output. Slower input-output traffic is handled by the Southbridge. The Southbridge connects the CPU to the ATA drive, USB bus, FireWire bus, serial port, parallel port, built-in audio, and ISA bus. The fetch and execute cycle. There are 4 steps to the fetch-execute cycle: read instruction pointed at by program counter, decode the instruction, obey the instruction, and increment program counter to point at next instruction. First proposed by John von Neumann. The fetch. The operation of the fetch is when information is obtained from the main memory. The registers are a sequence of steps that happens when the CPU fetches an instruction from the memory. It involves several registers inside the CPU, specifically the program counter. When the next instruction is to be fetched, this register is incremented by the appropriate number of bytes. The execution. When a computer obeys the instructions in a computer program, it is executing the program. Before a computer can execute a computer program, the program must be resident in memory. The program must occupy a set of consecutive bytes in memory and must be written in an internal machine language for the computer. Connection. At the beginning of each cycle, the CPU presents the value of the program counter on the address bus. The CPU then fetches the instruction from main memory via the data bus into the instruction register. From the instruction register, the data forming the instruction is decoded and passed to the control unit, which sends a sequence of control signals to the relevant function units of the CPU to perform the actions required by the instructions, such as reading values from registers, passing them to the ALU to add them together, and writing the result back to the register. The program counter is then incremented to address the next instruction, and the cycle is repeated. The instruction LDA number 7 in the 6502 assembly language means load the accumulator with the value 7. The sequence of instructions is now as follows. The CPU fetches the instruction LDA with the following value. The CPU is programmed so that when it receives this instruction, it fetches the next byte from memory. This is done by increasing the memory address register by 1, or using the program counter if the CPU doesn't have a memory address register, and fetching the next byte as per normal. The value read in is placed in the accumulator, thus replacing any value that was already there. Data flags are changed accordingly. Because the value is not 0, the 0 flag is cleared. Thank you for listening.